So let us solve this question. The solution of the partial differential equation dou u by dou t is equal to alpha times of dou square u by dou x square is of the form, which of this particular form? Standard forms actually, okay? So civil, basically, because this is the diffusion equation or one dimensional heat equation, okay? One dimensional unsteady state heat equation. So if you solve this equation, we get given PDE is dou u by dou t is equal to, u is mentioned or temperature T is mentioned? U is mentioned, fine. Dou u by dou t is equal to alpha times of dou square u by dou x square. Normally this alpha is called thermal diffusivity or diffusion constant basically. So if you see this, this is 1D heat equation, or it's also called diffusion equation. One dimensional diffusion, basically heat diffusion equation, or in general terms it's called diffusion equation. Now what would be the solution of this? So the general solution of this equation, the general solution of this PDE is y or u of x comma t is equal to c into basically e power minus c square p square times t into c1 cos px. Here instead of c square, alpha let us write, because normally we are habituated to write c here. So this is alpha p square t into c1 cos px plus c2 sin px actually here. And what about p actually here? P is given by minus k by alpha, correct? So this is p square is given by minus k by alpha actually. So that's how we write this alpha into p square is equal to minus k generally. So this is the p square what we assume during the derivation of this particular solution. In detailed course we have seen many times that how we have derived this equation. So this implies this u of x comma t is equal to c into e power. So when you assume p square as minus k by alpha in this derivation, minus alpha times p square is minus k by alpha times of t into c1 cos p. So p is square root of minus k by alpha times of x plus k can be negative, okay? So k is negative in this analysis. So sin root of minus k by alpha times of x actually here. So if you simplify, this value is c into this alpha minus minus gets cancelled. So e power kt times of c1 cos root minus k by alpha x plus c2 sin root minus k by alpha times of x. So this is the solution of this partial differential equation, okay? So let us check these options. So let us check this c e power kt into c1 cos root k by alpha. Okay, this k, if you take out the sign as some constant, this can be written as some constant k1 k2 whatever. So if you take this as k for example, then this option C is actually the correct answer of this particular case, okay? So because this k can be written as some constant actually, so that's why we can ignore the minus sign because it's arbitrary. It depends upon the boundary conditions and all. So option C is basically the correct answer in this case. Thank you.